Yeah, here we go. The shrinking, Salton Sea is shrinking and exposing toxic dust. And Salton Sea Geology 101, volcanic eruption is possible. What do you suppose that is?
It's TV's longest running hit drama.
Follow my lead.
This Wednesday.
We have a high priority situation.
Of course it does.
SVU returns Wednesday night.
So it's that tectonic interface we talked about there. That
2015 May, we traveled to California, Southern California. We flew to Los Angeles and then drove through the mountains to the desert. We actually went to Indio. We spent a week in Indio. It was an amazing place to be. It's the cities, the surrounding cities are Palm Springs,
so the point here is that
La Quinta.
geothermal energy is more abundant along the tectonic interfaces that we see, like we see here.
Can dehydrate and die in a matter of hours. It's the last place on Earth you'd expect to find any water at all, let alone a huge inland sea. This is the land of the Salton Sea in the desert of Southern California. An amazing 35 miles long and 15 miles across. Little known, largely ignored and misunderstood, this desert ecosystem is critical to hundreds of species, and it's in a lot of trouble. The Salton Sea and its drainage are located in the desert of Southern California. The Mojave Desert lies to the north, and to the south.
So we'll take a look here at some of the overlying
Gulf of
features.
California. The Salton Sea is home to hundreds of species. It's a place of unimaginable biodiversity, and it faces almost certain destruction unless something is done.
Let's see what check.
In Middle America. Here we'll focus on the Gulf of California rift zone. a divergent margin which is propagating into California.
This is what we just looked at
It is a transitional corridor that connects the
in
East
Google
Pacific
Earth.
Rise spreading ridge to the south with the San Andreas Fault Zone in California. Extension and strike-slip faulting are causing Baja California to separate away from mainland Mexico, thereby opening the Gulf of California as though it were being unzipped. In reality, the waters of the Gulf of California hide connecting stair-stepping seafloor spreading ridges with right lateral strike-slip motion on classic transform faults. This collection of faults and ridges forms a continental rift system that is tearing the Pacific plate apart from the North American plate. If we zoom in, we can see the processes occurring. As the lithospheric plates move apart, heat rises beneath the mid-ocean ridge. Magma forms at shallow pressures and creates new rock at the spreading ridges. The plates move away in conveyor belt-like fashion. Movement between the ridges is accommodated by transform faults where large earthquakes occur due to friction between the plates. Smaller earthquakes also occur along the ridges. Backing out to map view, we see the simplified San Andreas fault system cutting through California. As the movement of the plates continues along this plate boundary, it is forcing Baja California away from Mexico and causing Santa Barbara and San Diego to migrate northward towards San Francisco. Zooming into this smaller region for a more detailed look, we will go back 20 million years to watch how the Gulf and coastal areas developed. This animation by Tanya Atwater shows a tectonic model for the 20 million year evolution of the region, depicting the rotation of the transverse range blocks, the breakup of the continental shelf, as well as the opening of the Gulf of California as the Pacific plate grinds northward against the North American plate. The Baja California Peninsula and most of southwestern California is a remnant of the North American continent that was sheared off and moved to its present position. Earthquakes in the Gulf are more of a nuisance than a threat. However, the on-land part of this spreading ridge extends into Baja California, Mexico, and the Imperial Valley of California.
So the issue here is the transformal plate that you're looking at. When we got into Google Earth and zoomed out a bit, you could see that there was the subductive plate. Let's take a look at it here. And then that subduction is indicated by the 39 millimeters per year in the direction of the arrow here. So one aspect of the tectonic interface. What else we got around here? So we look at the coastal formation here, and as a subductive plate travels under the continental plate, it tends to bulldoze up, or as the plate subducts, the oceanic plate goes under the continental plate, it bulldozes up mountain ranges. You see here the coastal range, Sierra Nevadas, and then when you get into Nevada, how all these wrinkles and all this stress pattern tends to follow along this subductive or transformal tectonic interface between the oceanic plate and the continental plate, North American continental plate, suboceanic Pacific plate. But then we look up over here, well, what's this right here coming through Idaho? What's going on right here? See, let's get rid of some of these. First let's just take a look at it right here. You can see Yellowstone right here, the largest volcano that we know of on Earth. And that Yellowstone Lake that you see right here Grand Village Visitor Center, Yellowstone National Park, Yellowstone Lake, and this dome right in the center here. Recently they've determined that the water level on the south side, or this down by Peel Island and Molly Island, the south side of the lake, the water level's up some 2 feet, 2 plus feet. But the water level has not dropped on the north side. So they think that this whole area down here is lifting, perhaps. And that we'll look at the iris earthquakes and different seismology, and indicating that maybe there is something going on under Yellowstone. That's not it's not authentic that we just saw there. But what's interesting is that Yellowstone itself sits on a transverse, or the Snake River Rift, and if we go further west, take a look further west in the we'll see these mountain ranges. Red Rocks Lake, and then we've got the let's do this. So as we think of Yellowstone Lake over here now, here's our Yellowstone Lake, and we start to look west along the Snake River Rift. So the Snake River Rift runs transverse, or at a 90-degree angle roughly, to the tectonic interface on the west coast. So we got the Yellowstone Lake here, and then we've got the transverse, the subductive transformal plate along the coast. And then we've got the Snake River Rift that comes in and runs up through the craters of the moon, which they theorize was a previous eruption of Yellowstone. Craters of the Moon National Monument. Previous lava flows from that, the continental crust moving to the west, and the magma plume from the mantle being stationary. So way back when these eruptions may have occurred, and they've dated this lava. Craters of the Moon is a neat place if you haven't been there. So we've dated all these lava flows. I'd like to find Highway 93 going through there if I could. And that's the boundary. Yeah, here we go. Here's Arco. So we can follow Highway 93 right out of Arco, I bet. Yeah, there we go. Right along here. Center pivots. Remember, Idaho's potato country, right? So we are coming through, and volcanic soils are very rich. Here's Highway 93 coming into the craters of the moon. I didn't see the visitor center yet. Maybe this is it right here. Let's see. Here we go. Let's see if there's a picture right here. Oh. Through Twin Falls. showing. Got the Snake River. There it is right there. Okay, here we go. Kind of start to get a pretty good look at this rift. This interface is quite a gorge if you haven't been over it. There's the Snake River going down through there. Let's get down here and take a look at this thing. It's intense. Let's see if we can get to the ground level there. But the bridge doesn't really go. Doesn't really go over that. Doesn't come down like that. But this is quite the gash. The Snake River Rift. Looking south. Back northeast. Northwest. There you have it, the Snake River Rift, and it runs transverse. Kind of a point of interest up here is towards Chalice, Idaho. In here, Sawtooth and Chalice. Sawtooth National Forest, and you've got Craters of the Moon, so we want to go a little bit farther out. If you look right in here, you'll see Salmon River Mountains, and then there's Mount Bora. And this whole Springs Valley here, you notice that Leatherman Peak and Mount Bora, 13,000 foot mountains, 12,000 feet. $3,500 meters. 12,228 feet, excuse me. There's Leatherman Peak. And then this Springs Valley right here coming down through there. You can see how all these mountains have wrinkled up and reflect the coast of the western coast of the United States. And back in, I think it was I think it was as recent as 1987. The Springs Lake, they had a major earthquake where there's a large fault line that runs along the south side of this Leatherman Peak and Mount Bora. Let's see if this is Bora right here. Donaldson. Mount Reed Lake, let's go. This must be Mount Bora over here. There we go. Bora Peak. But now if we take it back out here ways. Now if we look along the south side of this, there's a nice earthquake fault zone. Where the mountains grew roughly 15 feet and the valley fell. Let's see if I can find that for you here. So if you ever get down in this neck of the woods here, you can really see this earthquake fault line here, where in general the valley dropped, Springs Valley dropped an average of 15 feet, and the mountains grew slightly. And this is the rift indicator right here, rift indicator. Rift. And they had gushers, I guess, that in the Springs Valley, that sand and geysers of water with sand in it were 25, 30 feet tall for several months after this earthquake in the late 80s. What's important here is you see how these wrinkles in these mountain structures along the Cascades and some of the volcanoes, like Lassen and Mount St. Helens. But an interesting look from if we get rid of these borders, kind of see a little bit more of that. Put those places away. And the other one right at the head of that transformal fault, the rift, Snake River Rift, right on through here. And that other sub-rift goes up, ends up coming out through. There's craters of the moon down here, it's pretty obvious. You can see there was some pretty heavy duty volcanic activity. And then we got these wrinkles here from the westerly movement, and then the easterly subduction. So there's a good example of your plate tectonics. And on your Google Earth, so download that, and we're going to be using that this year.